Mankind has made it his goal to push the envelope of travel, to go where no one has gone before, in order for others to follow. The advancement of travel has created the demand for the advancement of travel systems. There was a time when cutting through overgrowth was sufficient, and soon dirt roads covered with gravel got the job done. But later, forms of road construction had to advance into super infrastructures designed to withstand heat, cold, erosion, and tons of pressure. More importantly, highways and byways have become the billion-dollar arteries that keep our society on the move. Our means of travel continues to evolve for the better, and so will the system of roads. Eco Development Corporation presents the environmentally friendly roads of the future.
The first thing we're going to do today is to describe what actually took place in the preparation of the road, because it's a very simple concept and process, very similar to conventional road building technology. The road that I'm standing on right now, and that you'll see throughout the film, has a lot of sand content and a lot of clay. We built the first layer of 4 inches of sand and clay together and compacted it, which looks very much like the sand and the dirt that you see sitting right over here to the side. This is what this whole area looked like previously before we began doing anything to this particular road right now. The first 4 inches is a combination of sand and clay. After we compacted the first 4 inches, we brought in about 10 more inches of clay, of the red clay that you see sitting right over here that was dropped off by the dump trucks that we got from the surrounding area. This 10 inches of clay was then compacted and graded to the road that you see right in front of us. In the background, what you'll see right now is the cement truck is out actually laying powdered cement at about a 4% mixture with the clay on top of the road. This is going to be 96% less cement than a conventional road actually needs, which is going to be part of the reason we're realizing such a huge cost savings with our enzymatic road technology. The 4% cement that's going down right now is going down in a powder form. We're going to mix that with the tiller eventually right into the soil. They just took the moisture content and we found out that it's about a 9, and we're actually looking for a 15 as optimum. So we're going to have to add some more water to this with the enzyme, with the cement on top of the clay road. We're going to till everything together, and then when it cures, we're going to have a road that's going to be as hard as cement and a lot less expensive. One of the first things that we had to do in the whole process is send the core samples of the current road that we're standing on right now over to our lab in the Ukraine, because it's really the value-added engineering piece from our scientist Mikhail Jerabitsky that makes the whole process work and gives you the most efficient and most solid and strong road possible.
In every single location we are dealing with different types of soils and with different types of roads we want to build. So in order to make this process work and work efficiently, to get the best quality of road for this particular location, we require soil testing. The soil test will produce not just physical and chemical characteristics of soils, but they produce what kind of mixture we want to use, what kind of additives we have to add, like cement, dolomite, maybe some clay, maybe some sand, some particular soils, if any we have to add to that particular soil. After our lab will make a determination what we have to do, our engineer will calculate the necessary, the thickness of the road, how many cement, how many additive we have to use, and the so-called application protocol. After we send this application protocol to the customer start preparing the road base.
The reason why the enzyme works and the actual mechanics and science behind it is that the enzyme actually increases the surface tension of the water. The water, once it's mixed with the enzyme, can actually penetrate the soil molecules, which if the soil molecules has adequate fines in it, the fines grow tentacles that can interlock with the other molecules of soil and the enzyme and forms a very petrified bond, a molecular bond that's very, very strong, very high compressible strength, strong enough in some of our cases where we have 60-ton tractors and mining trucks that are running on the enzyme roads right now. What you see happening behind us right now, we're checking to see for the optimum level of water content in the soil right now, and we've just ascertained that we need another 1,000 gallons before we actually can go ahead and compact the road. So we're going to take the water truck, mix with the enzyme, put another 1,000 gallons on, and that should bring it up to about 15% moisture content, which is the content we need to have the strongest possible compression.
We just put enough enzyme in the water to treat the road. We just get ready to compact. We put 1 gallon. 1 gallon of enzyme for the 2,000 gallons of water. That's about it.
Well, it's an extremely hot day here in Clay County at Seamark Ranch in Jacksonville, and we've had to make several passes with the water truck to finally get it up to 15% moisture content, but we finally got it. We just got the thumbs up from the engineer. So right now we're making the last pass. We're going to go ahead and grade it to get flat, and then we're going to steamroll it and we're going to have a solid road.
And we've now put this stuff down 3 days ago. We've added a little water to it. We've hard planed it, and we're now getting ready to put down a little bit more water with some of the enzyme on this. And we're going to put an emulsion tar on it and put some coquine on it to seal all the moisture in and help maintain the surface on it.
Build a road that's going to be as hard as concrete, a little bit more pliable than asphalt, and it's going to cost us about 1/4 to 1/3 the price of a conventional road.